Welcome to Quantum Mechanics 23. Today's topic is expectation value and the related problems. Quantum Mechanics, expected value and related problems for BSc, MSc and CSC Net students. Expectation value and related problems, today's topic. The first topic is what is called expectation value. When we study operators and wave function, we see in quantum mechanics a term known as expectation value, which is actually an average value. When a measurement of a dynamical quantity like a momentum is made on a particle for which the wave function is psi, you remember this symbol psi, we get different values during the measurements. The most probable value of the dynamical quantity is called expectation value. നമ്മളൊരു മെഷർമെൻറ്റ് നടത്തുമ്പോൾ ഇപ്പോൾ മൊമെൻറ്റം അല്ലെങ്കിൽ എനർജി നടത്തുമ്പോൾ ക്വാണ്ടം മെക്കാനിക്സിൽ വേവ് ഫംഗ്ഷൻ വെച്ച് പാർട്ടിക്കിളിൻ്റെ എനർജി മൊമെൻറ്റം പൊസിഷനൊക്കെ അളക്കുമ്പോൾ അനേകം വാല്യൂ കിട്ടാം. അതിൽ നിന്ന് ഏറ്റവും പ്രോബബിൾ ആയിട്ടുള്ളത്, ഏറ്റവും ശരിയായിട്ടുള്ളത്, മിക്കവാറും ആവറേജ് ഏറ്റവും ശരിയായിട്ടുള്ളത്, ഏറ്റവും പ്രോബബിൾ ആയിട്ടുള്ള വാല്യൂവിനെ വിളിക്കുന്നത് ഇപ്പോൾ എക്സ്പെക്റ്റേഷൻ വാല്യൂ. നമ്പർ ഓഫ് റിസൾട്ട്സ് നമുക്ക് കിട്ടിയാൽ ഒരു പരീക്ഷണം എക്സ്പെരിമെൻറ്റിൽ ഇപ്പം മൊമെൻറ്റത്തിൻ്റെ എനർജിയുടെ അനേകം വില കിട്ടിയാൽ അവയിൽ ഏറ്റവും പ്രോബബിൾ ആയിട്ടുള്ള വാല്യൂ അതിനെ വിളിക്കുന്ന പോലെ എക്സ്പെക്റ്റേഷൻ വാല്യൂ. യു സി വെൻ എ മെഷർമെൻറ്റ് ഓഫ് എ ഡൈനാമിക്കൽ ക്വാണ്ടിറ്റി ലൈക്ക് മൊമെൻറ്റം, ഒബ്സർവബിൾ ലൈക്ക് മൊമെൻറ്റം എനർജി പോലെയുള്ളവയെ ഡൈനാമിക്കൽ ക്വാണ്ടിറ്റി എന്ന് പറയും. വെൻ എ മെഷർമെൻറ്റ് ഓഫ് എ ഡൈനാമിക്കൽ ക്വാണ്ടിറ്റി ലൈക്ക് മൊമെൻറ്റം ഈസ് മെയ്ഡ് ഓൺ എ പാർട്ടിക്കിൾ ഫോർ വിച്ച് the wave function is psi, we get different values during the measurements. The most probable value of the dynamical quantity is called its expectation value. എങ്ങനെയാണ് എക്സ്പെക്ടേഷൻ വാല്യൂ എഴുതുക? യൂസ് ഹിയർ. It is represented as a expectation. രണ്ട് ഈ ഡിസ്റ്റോർട്ടഡ് ബ്രാക്കറ്റ്, രണ്ട് ഒടിച്ച ബ്രാക്കറ്റ് ഉണ്ട്, അതിനകത്ത് നമ്മളൊരു എ ഇടും. ഒരു ബ്രാക്കറ്റ് മടക്കി വെക്കുന്നതിന് അതിനകത്ത് എ ഇടും. നിങ്ങൾക്ക് ഏറ്റവും ലെസ് സൈൻ പോലെ ഇട്ടിട്ട് അതിനകത്ത് എ എഴുതും. അതിന് വിളിക്കുന്ന എപ്പോഴാണ് എ എക്സ്പെക്റ്റേഷൻ. ഇത് വായിക്കണം. എക്സ്പെക്റ്റേഷൻ എ അല്ലെങ്കിൽ എ എക്സ്പെക്റ്റേഷൻ എന്നാണ് വായിക്കുന്നത്. എഴുതാൻ മനസ്സിലായെന്ന് തോന്നുന്നു. ഇപ്പോൾ എയുടെ എക്സ്പെക്റ്റേഷൻ ആണെങ്കിൽ ഈ രണ്ട് ഈ ചെറിയ ഒടിച്ച ബ്രാക്കറ്റിനകത്ത് എ ഇടും. പിന്നെ പി ആണെങ്കിൽ പി എക്സ്പെക്റ്റേഷൻ, പി അകത്ത് എഴുതണം. ഏത് വാല്യൂ ആണോ അതാണ് ഈ രണ്ട് ബ്രാക്കറ്റ് കഷ്ണങ്ങളുടെ അകത്ത് ഇടുന്നത്. എക്സ്പെക്ടേഷൻ വാല്യൂ ഇസ് ഡിഫൈൻഡ് ബൈ ദി ഇക്വേഷൻ. അതിനൊരു പ്രത്യേക ഡെഫിനേഷൻ ഉണ്ട്. ബൈ ദി ഇക്വേഷൻ എ എക്സ്പെക്ടേഷൻ ഈസ് ഈക്വൽ ടു ഇന്റഗ്രൽ മൈനസ് ഇൻഫിനിറ്റി പ്ലസ് ഇൻഫിനിറ്റി സൈ സ്റ്റാർ എ സൈ ഡി ടു. അപ്പോൾ എൽ എച്ച് എസ് എൽ എ, ആർ ടി എസ് എൽ ഈ ക്യാപിറ്റൽ എ ഉണ്ട്. അപ്പോൾ ഈ സൈ സ്റ്റാർ സൈഡിൽ ഇടയ്ക്കാണ് നമ്മൾ ക്യാപിറ്റൽ ഇട്ടിരിക്കുന്നത്. അങ്ങനെയാണ് എക്സ്പെക്ടേഷൻ വാല്യൂ ഡിഫൈൻ ചെയ്യുന്നത്. യൂസ് ഈ ഡെഫിനേഷൻ. A expectation is equal to integral minus infinity 2 plus infinity psi star a psi d2. d2 is the only element. That is equation number 1. Where is the operator of the dynamical quantity? You know operator. We have studied two operator or three operator. One is E operator, other is H operator, and another E operator. IH got a dou by dou t. Three operators. Already we have studied H operator, E operator in terms of time, and also moment operator. Moment operator I am repeating here. You look here. Expectation value A expectation equal to integral minus infinity to plus infinity psi star a psi d2. Equation 1, where A is the operator of the dynamical quantity. For example, the expectation value of momentum is given by P expectation equal to integral minus infinity to plus infinity psi star P op psi d2. P op is minus IH got dou by dou x. You look here. What is written in the bracket is operator for momentum P op, that is minus IH get dou by dou x. You know E op IH get dou by dou t. Here it is P op, operator for P, minus IH equal to dou by dou x. And this is the expression for expectation value of momentum. Some other examples are also written here. Next is expectation value of energy is given by E expectation is equal to integral minus infinity plus infinity psi star E of I h dou by dou t psi d2, where E of is I h dou by dou t, no minus. Expectation value of a position coordinate is x expectation or r expectation is integral minus infinity to plus infinity psi star r. R and operator r thanneയാണ്. Operator of r is r itself. Psi d tau or dx. When r is considered, we need only a position coordinate. No volume element is required. Equation 1 represents the expectation value. Where is equation 1? Equation 1 is given in the next previous slide. Integral minus infinity plus infinity psi star a psi d2. That is equation 1. Equation 1 represents the expectation value of a normalized wave function. But normalized wave function expectation value ആണെന്ന് പറയുന്നത്. നോർമലൈസേഷൻ നമ്മൾ പഠിച്ചതാണ്. നോർമലൈസേഷൻ ഒരു ഫംഗ്ഷൻ ഉണ്ടെങ്കിൽ അതിനകത്ത് കോൺസ്റ്റന്റ് എ കൊടുക്കാം, എൻ കൊടുക്കാം, എൻ കണ്ടുപിടിക്കുന്നതിനാണ് നമ്മൾ നോർമലൈസേഷൻ എന്ന് പറയുന്നത്. അപ്പൊ ഈ മുകളിൽ കാണുന്ന രീതിയിൽ നമ്മൾ എഴുതിയാൽ അത് നോർമലൈസ്ഡ് വേവ് ഫംഗ്ഷന്റെ എക്സ്പെക്ടേഷൻ വാല്യൂ ആണ്. ഈ ഫംഗ്ഷൻ നോർമലൈസ്ഡ് അല്ലെങ്കിൽ എങ്ങനെ എഴുതും? Equation 1 represents expectation value of a normalized wave function. If the wave function is not normalized, then the expectation value is given by A expectation is equal to integral over tau psi star a psi d2 by integral over tau psi star psi d2 or dx. We can write d2 volume element. അവ നോർമലൈസ്ഡ് ആണെങ്കിൽ നോർമലൈസേഷൻ അറിയാമല്ലോ. ഇപ്പോൾ സൈ ഈസ് ഈക്വൽ ടു എ സൈൻ എൻ പൈ ബൈ എൽ എന്നൊക്കെ പറയുന്നത് നമ്മൾ. അപ്പോൾ ആ കോൺസ്റ്റന്റ് ക്യാപിറ്റൽ അറിയാമെങ്കിൽ അതിനെയാണ് നമ്മൾ നോർമലൈസ്ഡ് ഫംഗ്ഷൻ എന്ന് പറയുന്നത്. ഫംഗ്ഷൻ നോർമലൈസ്ഡ് ആണെങ്കിൽ നമുക്ക് മുകളിൽ കാണുന്ന പോലെ എക്സ്പെക്ടേഷൻ വാല്യൂ എഴുതിയാൽ മതി. ഇനി നോർമലൈസ്ഡ് അല്ലെങ്കിൽ ഈ കാണുന്ന പോലെ ഒരു ബൈ ഫാക്ടറോട് കൊടുക്കണം. ദാറ്റ് ഈസ് എക്സ്പെക്ടേഷൻ ഇസ് ഈക്വൽ ടു integral over tau, that is minus infinity to plus infinity psi star a psi d2 by integral psi star psi d2, and this is the representation of expectation value for a function which are not normalized. If it is normalized, no denominator is required. I think it is clear what is expectation value and how will you define it. You read it once again. And here I give one or two problems based on normalization and expectation value. Normalization and expectation value problems. Two problems are here given, very important. This is a question, a university question. Normalized wave function psi is equal to a sin, psi is equal to a into e raised to minus x square, where a and a are the constants of the domains. Domain is missing here. It is domain is minus infinity less than or equal to x less than or equal to plus infinity. You read the domain. It is missing there. It is written here minus infinity less than or equal to x less than or equal to plus infinity. The meaning is x is in between minus infinity and plus infinity. That is the domain, the range of integration. I shall read the question once again. Normalize the wave function psi is equal to a e raised to minus ax square, where a and small r constants over the domain minus infinity less than or equal to x less than or equal to plus infinity? That's the question. I think the question is clear. Normalize the wave function psi equal to a into e raised to minus ax square, where capital A and small a. Small a is here on the left side. Capital A and small a are the constants of the domain minus infinity less than or equal to x less than or equal to plus infinity. So we start the answer. Given psi is equal to a raised to minus a square. Normalization involves the calculation of a. Normalization എന്ന് പറഞ്ഞാൽ ആ a എന്നുള്ള കോൺസ്റ്റന്റ് കണ്ടുപിടിക്കുക എന്നുള്ളതാണ്. The normalization condition. We write now the normalization condition. Normalization condition is, condition is integral minus infinity you write. Integral minus infinity to plus infinity such that psi dx is 1. That we have studied. Normalization condition minus infinity to plus infinity such that psi dx. Here dx is sufficient because the function is in x, one dimension. So d tau is needed, dx is sufficient. So we write the normalization condition as integral minus infinity to plus infinity such that psi dx is 1. That is the normalization condition. And in that equation we put the given function and its complex conjugate. Here psi is equal to a into e raised to minus ax square. There is no I. So psi and psi star are same. No change in psi star. If there is psi, the function changes. Plus psi becomes minus I. If there is no I, psi and psi star are same. So I will put psi and psi star in the equation. That is integral minus infinity plus infinity a e raised to minus ax square. That is psi star. Then psi a e raised to minus a square dx is 1. And a multiplied, we can take out. There is no operator, so we can take out a square. A square integral minus infinity to plus infinity e raised to minus 2a square dx is 1. You know a raised to m into a raised to n. A raised to m plus n. Here e raised to minus a square into e raised to minus a square. So we get e raised to minus 2a square. So the normalization condition reduces like this. And this integration, this is standard integration. And that you that you have studied in complementary mathematics. It's a standard integral. Its result is, you look here, it is written here. We need not to prove here. You only remember the result. That is given in the standard integral formula. Standard integrals. It is one of the standard integrals. Not given in tables, but in mathematics you study. In mathematics, this integral is given as very important. That is integral minus infinity to plus infinity e raised to minus 2x square dx is equal to root of pi by 2a. That is a standard integral, and that we note from the table of standard integrals. You study in you have studied, or you are finalists, so you have studied this in your complementary mathematics. So this value we put in the above equation. That is a square into the integral value. Root of pi by 2a is equal to 1. We rewrite. The step we rewrite. A square into root of that we cross multiply. A square is equal to root of 2a by pi. That we can write, a root can be written as raised to 1 by 2. A square is 2a by pi raised to 1 by 2. That is a is equal to 2a by pi raised to 1 by 4. Pi is in the denominator. You have to add a is equal to 2a by pi. That is removed from there on cutting. So a is equal to 2a by pi you just see the above line, and from that line you write a 2 by pi the whole raised to 1 by 4. 1 by 2 becomes 1 by 4 when the root is taken. A is equal to 2a by pi the whole raised to 1 by 4. That is a normalization constant. So what is normalized wave function? Here it is. The normalized wave function is psi is equal to a, capital A, that is 2a by pi raised to 1 by 4 e raised to minus a square. അപ്പോൾ നോർമലൈസേഷൻ എന്ന് പറഞ്ഞാൽ ഈ ഫംഗ്ഷന്റെ കൂടെ വരുന്ന കോൺസ്റ്റന്റ് ക്യാപിറ്റൽ എ ആണോ അല്ലെങ്കിൽ ക്യാപിറ്റൽ എൻ ആണോ അത് കണ്ടുപിടിക്കുന്നതാണ്. ഇവിടെ നമ്മൾ കണ്ടുപിടിച്ചപ്പോൾ കിട്ടിയത് 2a by pi raised to 1 by 4 ആണ്. അതും കൊടുക്കുക. The constant, the normalization constant obtained here is 2a by pi raised to 1 by 4. We put it in the relevant position, in its position, that is psi is equal to 2a by pi raised to 1 by 4 e raised to minus a square. That is the normalized wave function. Now comes another problem. A particle constrained to move along x-axis in the domain 0 less than or equal to x less than or equal to L. L has a wave function psi is equal to sine n by x by L, where n is an integer. N is an integer. Normalize the wave function and evaluate the expectation value. So this is a question containing two answers. First we have to normalize and then we have to find expectation value. Two questions. The wave function is given psi is equal to sine n by x by L. The domain is given x is in between 0 and L. That is 0 less than or equal to x less than or equal to L. The meaning is x is in between 0 and L. We have to normalize function and also we have to find the expectation value. ഈ തന്നിരിക്കുന്ന ഫംഗ്ഷൻ നോർമലൈസ് ചെയ്യണം, അതിനൊപ്പം തന്നെ അതിൻ്റെ എക്സ്പെക്ടേഷൻ വാല്യൂ കണ്ടുപിടിക്കണം. പൊസിഷനാണ് എക്സ് ആണ്. So look here. The normalization condition is expectation value of its moment ആണ്. നമുക്ക് കാണേണ്ട expectation value of its moment അതാണ് കണ്ടുപിടിക്കേണ്ടത്. Answer we write normalization of wave function condition is integral first limit to second limit. Here 0 to L. 0 to L psi star psi dx is equal to 1. We integrate with respect to x. Here x function is given. The function is sine n by x by L. X is the variable. You look here, there is no a. Actually, we have to put a and find that normalization constant. Here, normalization constant is not given, but we can put one. That is its property. Even if there is no capital A in front of sine, we can put an a and we calculate its value. That is the method of normalization here. You read. Here, no normalization constant. ഇവിടെ നോർമലൈസേഷൻ കോൺസ്റ്റന്റ് ഇല്ല. No normalization constant given with function. We have to incorporate one. നമുക്ക് ഒരെണ്ണം ചേർക്കണം. That is psi is equal to a sine n by x by L. We have put capital A. Now you write the normalization condition. That is integral psi star psi dx is 1. We write equation 1. We write that is integral 0 to L a sine n by x by L into a sine n by x by L dx is equal to 1. dx is equal to 1. That is a square, a into a square, integral 0 to L sin square n by x by L, 0 to L, limit is 0 to L, 0 to L sin square n by x by L, dx is 1. You know the integration of sin square x, that you know, sin square kx, you know how to integrate. For that we have to write sin square x, we have to write sin square x, we have to write half of 1 minus cos 2x in that manner. In order to integrate sin square x, we have to write half of integral 1 minus cos 2x. So a square integral 0 to L half of 1 minus cos theta is x is n by x by L. So 2n by x by L dx equal to 1. And here we have to remember one thing. If we integrate cos 2x or sin 2x, for this limit, if you get 0, that 0 is marked above. When a cos 2 function or sin 2 function is integrated for 0 to L, we get that integral 0. So the second integral is 0. So what is remaining is a square half 1 dx integral, that is x. Then we put the limit outside the bracket 0 to L. Put the limit a square by 2 into L minus 0. L is equal to 1. That is a square is 2 by L. A is root of 2 by L. That is the normalization constant in this case. So we write the normalized wave function. Here is a normalization condition constant we have obtained. Normalized wave function, therefore, psi is equal to A, that is root of 2 by L sin n by x by L. That's the method. Now we can find expectation value for momentum. Expectation value for momentum is also asked. You know, the definition for expectation value is P expectation is equal to integral 0 to L psi star P op psi dx. When we want to find expectation value, we write the respective operator in between psi star and psi in the RHS. For momentum, the operators for the time being, we can write as P op. Now we put the value P op. That is P expectation is equal to integral 0 to L psi star P op. I told you minus h cut dou by dou x. That is the operator for momentum psi dx. That is P expectation. Second step, P expectation is equal to integral 0 to L root of 2 by L. We give the normalized wave function sin by x by L inside a bracket P of minus I h d dou by dou x into root of 2 by L sin n by x by L dx. That is P expectation is 2 by L. When there is a constant in the bracket that we can take out without any change. Minus h cut integral 0 to L sin n by x by L dou by dou x of sin n by x by L dx. So there are 2 root of 2 by L. First one, second one. On multiplying, we get 2 by L. There is no root in the second equation. Root 2 by L into root 2 by L is 2 by L. So 2 by L into minus I h cut integral 0 to L sin n by x by L dou by dou x of sin n by x by L dx. It is clear. That is P expectation. Last step. Minus 2I h cut by L. We multiply. Minus 2I h cut by L integral 0 to L sin n by x by L. Then we differentiate the term in the bracket. When we differentiate, sin becomes cos and that constant will run to the front side. So the constant is written n pi by L cos n pi x by L dx. When we differentiate sin n by x by L, we get cos n by x by L multiplied by constant n by x by L. that constant is written in front. Now you look, that is 2IH cut. That is minus, look here, that 2 is taken inside. In order to integrate sine and cos, we have to take it to 2 inside. So there is no 2. Minus h cut, IH cut by L into n pi by L integral 0 to 2. The 2 is taken from the front. 2 sine n pi x by L cos n by x by L dx is equal to minus IH cut n pi by L square integral 0 to L. You know 2 sine theta cos theta is sine 2 theta. So sine 2 pi x by L dx. And if you integrate this sine 2 n pi x by L for 0 to L, we get to 0. So put to 0 there. So P expectation is equal to minus I by h cut n pi by L square into 0 equal to 0. So P expectation is equal to 0 for this problem. And here remember one thing. One more thing you remember. We have done the integration with the limits 0 to L. And if you perform this problem for a limit, you look here what I have written in the side of the slide. We did the problem with the limit 0 to L. And if we perform the same problem for a limit minus a to plus a, that can be also asked. Then the normalization condition is integral minus a to plus a psi star psi dx is equal to 1. And if we put this limit and integrate in the same manner, we get a normalization constant 1 by root a. 1 by root a. So this you do as a homework. The function is sine n by x by L. We put a constant a and normalize. The normalization limit is minus a less than or equal to x less than or equal to plus a. So limit is minus a to plus a. And if we normalize for this limit, the normalization constant will become 1 by root. You try it. Change the limit and integrate the same function. And you see the change in the normalization constant as 1 by root a instead of root of 2 by L. And that is all with your 23rd lecture on quantum mechanics. This is somewhat lengthy. You have to study well. And the next class we take admissibility condition of wave function in the next lecture. Thank you very much.